We're now going to take a look at naming compounds that have things in them called polyatomic ions. This is IONS. It isn't the same as the metal iron, IRONS. Polyatomic ions, poly, many, atomic, atoms. Ions means a charged particle. So, for example, when you have potassium and it's lost one electron, it will become K+. When you have chlorine and it's gained one electron, it will become Cl-. The fact that it's got an extra or a shortage of electrons, an extra and a shortage of electrons, means that you have got an ion. Sometimes polyatomic ions are called radicals. So, what do we mean by polyatomic ions defining in definition terms? Sometimes a small group of atoms associate with one another so closely that the group is given a valency. These groups of atoms are negatively or positively charged. That makes them ions. And charged atoms are called ions, as are charged groups of atoms. So let's see how we're going to use that. You will be given this list of polyatomic ions in a test or an exam. You do not need to learn them, you just need to know how to use them. However, you do need to be somewhat familiar with them in the sense that you are going to have to be able to spot them quite quickly. So, ammonium is not the same as ammonia. It's NH4+. Silver and zinc I just give you always because silver's always got a valency of 1. Remember, we've talked about this before. And zinc has always got a valency of 2. Remember, we've talked about that before. So you land up with those in the list. Although they are not polyatomic, they are very standard ions. All right. Permanganate, Mn, capital M, little n, O4, with a charge of 1 and a valency of 1. Notice the plus. If it's +1, it's got a valency of 1, 1 arm. If it's +2, it's got a valency of 2. If it's 3 plus or minus, it's going to be a valency of 3. 1 minus, valency of 1. 2 minus, valency of 2. So the charge is always equivalent to the valency. So permanganate, there's manganese and oxygen, and together it has a valency of 1. Nitrate, NO3, which is different from nitrite, which is NO2 with 1 arm. And nitride, remember the "ide" suffix means it came straight off the periodic table, and that's really just nitrogen. It's in group 5, so 8 minus 5 is equal to 3, and then you've got a valency of 3. Hydroxide is your one exception to this "ide" suffix. It is actually a polyatomic ion. It's oxygen and hydrogen together with 1 arm. Chlorate is chlorine and oxygen. Bicarbonate, hydrogen, carbon, and oxygen with a valency of 1. Sulfide comes straight off the periodic table again. It has the "ide" suffix, and it's just sulfur with 2 arms because it's in group 6. That means that there are 8 minus 6 arms. Sulfate, SO4 2 minus. Sulfite, SO3 2 minus. Carbonate, CO3 2 minus. Chromate, CrO4 2 minus. Dichromate is a tricky one. It's long and complicated, but it's going to be given to you, so don't worry. It's Cr2O7 2 minus. Don't forget lowercase r, uppercase O. And then phosphate is PO4 3 minus. So once you've become familiar with these, you can use them. Let's see how we're going to use them. It says write the chemical formulae for calcium sulfate. So let's do that. Calcium is Ca, and it is over here, which means it is in group 2, which means it has 2 arms. Sulfate off the list is SO4, and instead of writing 2 minus, I'm going to put a circle around it, say it's a group of things, and I'm going to give it 2 arms. Those are representing the 2 electrons that participate in bonding. Holding hands, the formula for calcium sulfate is therefore CaSO4. If I want to do sodium carbonate, sodium is over here on the periodic table, which means it has a valency of 1, Na, valency 1. Carbonate is on the list, CO3, 2 minus, I put it in a circle and I give it 2 arms. Hold hands. Another sodium, and we hold hands. And that is Na2 because there are 2 sodiums, so I must make sure that I've got a 2 over there, and CO3. The next one is iron nitrate. Iron is Fe, and it is over here in the transitions, which means I don't know its valency, but they've given me the valency with the stock notation and told me it has 2 arms. And then you've got nitrate, and nitrate is NO3 with 1 arm. Put a circle around it, give it 1 arm, and I hold hands and I need another nitrate, so I put another entire nitrate group there and then hold hands like that. That means that I have got 1 Fe and 2 nitrate groups. The way I represent that is I put a bracket around the nitrate group and a subscript 2. Now it's important, in the same way as it's inappropriate to use stock notation when you don't need it, it is inappropriate to use brackets when you don't need them. So, if you've only got one of the polyatomic group, you do not use brackets, as in this case here with the carbonate. If you've got 2 sodiums, you do not use brackets to symbolize that you've got 2 of a single atom. You only use the brackets when you have got more than one of a polyatomic group. Then you use the brackets in order to symbolize that the group is duplicated in the molecule. Also notice that in every single formula, I never, ever, ever, ever write stock notation in a formula. The stock notation is only written in the name of a compound. So this is this all neatened up.